A curve has equation here, y given by this equation, which is a cubic. Sketch the curve indicating the coordinates of all points of intersection with the axes. Show that the gradient of the curve at the point P, 1, 0, is 4. The line L is parallel to the tangent to the curve at the point P. The curve meets L at the point where x is minus 2. Find the equation of L. Giving your answer in the form y equals mx plus c, determine whether L is a tangent to the curve at the point where x equals minus 2. Okay, so let's have a look at this then. So what have we got then? Here's our cubic equation, so let's paste in an axis. And now we want to mark off the roots, don't we, first of all? So this would be minus 3, this would be a half, so I'm going to put that in there. That coordinate there is a half. Naught. Then this coordinate here is 1 naught. And then this coordinate would be minus 3, wouldn't it, back here? And that would be the other coordinate where it crosses the x-axis. When it crosses the y-axis naught, so put naught in all three. Okay. 3 times minus 1 times minus 1 is 3. So this cutting point is at 3. 0, 3 rather. And that's that point there. So I'm going to do a dashed line for the sketch because I've got a digital pen, so it's not easy to draw with a straight line, smooth straight line. So it turns, comes back up through there, and then it needs to go down, doesn't it? So it turns and goes back down. So it should go up a bit more here, shouldn't it? So maybe I'll draw that in a bit better. So it's going to come over here and then swing back down through there, and that's the curve. Sketch y showing the axis crossing points and the coordinates we've done. So show that the gradient at P1 naught is 4. So here we've got y is equal to 2x minus 1. Expand the bracket then, x squared. Let's do these two, it's easy to do. Minus 1 plus 3 is plus 2, lots of x. And then 3 times minus 1 is minus 3. So that's equal to, run the 2x through, so it's 2x cubed. 2x times 2x is 4x squared. And then 2x times minus 3 is minus 6x. Run the minus 1 through, minus x squared, minus 2x next. And then plus 3, isn't it, when we times it by minus 1. Minus times a minus is a plus, so y is equal to then 2 lots of x cubes. 4 minus 1 is plus 3 lots of x squared. And then minus 6 minus 2 is minus 8 lots of x plus 3. So there's our y as a cubic function. And now we can get dy dx for part 2 then, the gradient at P1 naught. So part 2, dy dx is equal to 6x squared, isn't it? The 2 comes down to be with the 3 to make 6x to the 1 less, which is power 1. X goes to 1 and there's minus 8 lots of 1, which is minus 8, and the constant goes to 0. Now that equals then, that equals, when x is 1, put it in, plus 6 times 1 minus 8 equals 12 minus 8. 6 plus 6 is 12, take 8 is 4. And that's when x is 1. So we can say now the gradient, that's part 2, the gradient at when x is 1 is 4. L is parallel to the tangent at P. And the curve meets L at x equals minus 2. So part 3 then is parallel to the tangent at P, so L has gradient 4. Passes through, L passes through x equals minus 2, and the curve value when x is minus 2, put it in here, minus 2 times 2 is minus 4, minus 1 is minus 5, and then get the other values. Minus 2 plus 3 is 1, and minus 2 minus 1 is minus 3, so it's 1 times minus 3. and that gives us 15. So it passes through that coordinate. So y minus the y value, 15, is equal to the gradient, 4, x minus the x value, which is minus 2, so it changes to a plus 2. So we want the form y equals mx plus c. 4x, 4 2s are 8, move the 15 over to plus 15, 8 plus 15 is 23. Y equals 4x plus 23, so that's the line L. Determine whether L is a tangent at x equals minus 2. So that it goes through it cuts the curve. Now at x equals minus 2 then, what's the gradient of the curve? We need to see that it's 4. dy dx is equal to, here it is here, 6 times minus 2 squared plus 6 times the minus 2 minus 8. Minus 2 squared is 4, 6 4s are 24. Minus 12, minus the 8. 24 take 20 is 4, so it is a tangent. So L is a tangent.